Everyone. Today's topic is Circle Theorem Part 1, another topic in our revision booklet. So let's get started. We will learn about the circle theorems, including their applications, proof, and how to use them to solve more difficult problems. Which are those circle theorems? Those are here, these are the main 7 circle theorems which we are going to learn about, and they have a relationship between angles within a circle's geometry. And using these theorems and a prior knowledge of your angle properties, you can calculate missing angles without using a protector. And there are a number of uses of this in the field of design and engineering. Now in the next slides, we are going to learn about the summary of each circle theorem along with a diagram. You need to remember all these circle theorems rules and be able to describe each one in exam questions. Before we start going through each of the circle theorem, it is important we know the names of each part of the circles, as we will be using these terms in this section. And to solve hard problems, you may need to use the angle facts you are already familiar with from triangles, polygons, and parallel lines. You may also have to use circumference and area formulas to ensure you are familiar with circumference, which is pi d, and the area, which is pi r square. Part 1, we are going to learn about 3 circle theorems out of 7, including their application, proofs, and how to use them to solve more difficult problems. Now this circle theorem, this part of the circle theorem is named as angle at center and circumference, in which we usually find 3 main circle theorems, which are the angle at the circumference in a semicircle, angles at the circumference subtended by the same arc are equal, and angle subtended by an arc at the center is twice the angle at the circumference. Now here is one exam tip for you all, that add anything you can to the diagram you have been given. Write in any angles and length you can work out, even if they don't seem relevant to the actual questions. So for each angles you work out, try to assign an angle fact or a circle theorem to it. Questions often ask for reasons and the names, titles, or phrases for each of these in exactly what they are after. When asked to give reasons, aim to quote angle facts or a circle theorem for every angle you find, not just one for the final answer. First circle theorem is the angle in a semicircle is 90 degrees. Now in this theorem, look for a triangle whose base is a diameter of a circle and diameter is a line which is going through the center. And the angle at the circumference in this triangle will always be a right angle. Now let's prove this theorem. To prove the angle at the semicircle is right angle, we have to say the angle on a straight line, which I would say on my diameter, which is from this part to this part, it is my straight line. And when I say on the diameter, it means the angle on a straight line is 180 degree. When the angle on a straight line is 180 degree, if I am trying to find the angle on a half of the semicircle, it says A is equal to half of the angle which is on a straight line, which is going to say half of 180. So I'll get 90 degree. Hence, the angle in a semicircle is 90 degree. Another example of the same theorem. Here's a circle given and the triangle given. Now they are saying find out the size of the angle B. So it means they are trying to ask us to find the size of this angle B. Okay, and we have to prove again whether this angle is 90 degree or not. Okay, now what we're going to do here is first we have to see whether this triangle is passing from the base of the triangle is diameter or not. So I can see yes, the base of the triangle is a diameter because this is my midpoint. Okay, we can see this is my midpoint, and from here there is another line which is passing as a radius and touching the edge of the circle. So it is making these one triangle into two equal triangle which has two equal sides and making it as an isosceles triangle. And isosceles triangle means our base angles are equal, which says my angle x will be equals to this angle x, and my angle y will be equals to this angle y. Now, after doing this, I'll take the equation which says the angle in a triangle add up to 180. So if I take this equation, I'll say that x plus y is equal to 180. It means I have taken these two x plus y together. Okay. Now in that case, following the equation, 2x plus 2y is equal to 180. And if I divide both the sides by 2, which will make it x plus y is equal to 90. So this says, and it shows that our theorem is right. And the angle in a semicircle is a right angle. Theorem, you can find these angles in any side of the circle, whether it's top, bottom, or to the sides. And sometimes you may be given this kind of quadrilateral, and you have to make sometimes the middle line might not be given, and if you can see or if you can make that center diameter and try to work out of your quadrilateral by making it two triangles, you can easily find the answer of your question. Here are some examples for you to try. Give it a pause and try it by yourself. Here are the answers. So first I have to see the straight line. It means 180 minus 121 will give me the answer of 59. So my interior angle is 59, and to find the angle x, 59 plus 90 degree, because of the angle in a semicircle is a right angle. I'll find my equation and I'll find my answer saying 59 plus 90 is equal to 149, and 149, if we minus it from 180, I'll get the answer 31. Now, is there another example for you to try? Please give it a pause and try it by yourself. I hear the answer for you all. This is how you need to give all the reasons when you're answering the questions of your circle theorem questions. Theorem 2 says the angles subtended by the same segments are equal. And if I say segment, so here my segment is A to B. Okay, this is my segment here. This entire thing between the chord and the arc I have made, this is my segment. So if I'm making any angle from my 2 points of this chord or the segment, then the angle which I am making on the other side of the circumference will be equal. Our other point is, if I will pass my angles from point, circumference, point, then again point, circumference, point. It means my angle C and D will be equal. So it means my angle C and D will be equal if I follow the rule of point, circumference, point. Let's review this one more time with another example. To prove our theorem 2, which says this angle at the same segment or the same arc are equal. So in the circle, what I'll do, this is the another way of finding the equation, that I'll make my two radius from the center of the point to the point of the arc, which is like this. From this point I have made this line, and from this point I have made this line. So this is my arc. Okay, I have joined these the end of those 2 points of the arc with the center, with the radius. Now what I'll say, that angle on my circumference x is twice the angle in the middle, and angle y on circumference is twice the angle y in the middle of the circle. If I take this equation, I can say green angle is twice the angle red. Similarly, green angle is twice the angle purple, which means 2x is equal to 2y. And if 2x and 2y are equal, which means if I divide both the sides by 2, I can get x is equal to y, which means angles subtended by the same arc are equal, or angles subtended by the same segment, this is my segment, are equal. Equation on the similar theorem here shows that the angle x and angle y are equal and always equal. Now we need to show this. We need to prove this. If you wanted to try it by yourself, pause the video and try to answer this question. So if the center angle at the center of the circle is twice the angle at the circumference, which means that the angle x is 2x in the middle and angle y is 2y in the middle, which means they both are equal. Divide by 2, which means x is equal to y. So angle in the same segments are equal. Now angle in the same segment are equal are not only just on the top, so it can be in any direction. You just have to look for your right theorem and apply it there. You need to look for the segment or the arc, whether they are subtended with the same point or not. Now here are some examples for you to try. Find the value of angle marked x. Give reasons for your answer. Remember, with each and every solution you are going to do for this question, you have to give the reason for your answer. So for example, I have been given the straight line and one side is 128. If I take the straight line rule, the angle add up to 180. It means 180 minus 128 will give me 52. If that is 52 and I follow my circle theorem rule, then my x is also 52. This is how we need to write the answer. Now there is an example 2. Find the value of marked y. Give reason for your answer. Now here it's bit tricky, looks bit tricky, but it's not. So what I'll do, I'll look for my isosceles triangle. In isosceles triangle, I have been given 94 degree already in the middle, and the rule of isosceles triangle is the base angles are always equal. So what I'll do, 180 minus 94 is 86 and 86 divided by 2 is 43. So my base angle in isosceles triangles are 43. Now if I take the rule of the circle theorem, I know that one side of the angle on a circumference is 72, which means if I minus 43 from 72, I'll get my angle y, which is 29. Theorem 3. The angle at the center is twice the angle at the circumference. Now similar to above, the chords to the center and the chords to the circumference are both drawn from the end of the arc. Okay, and our arc here is, can say P here and Q here. Okay, so has been subtended from the arc P and Q. And this theorem can also happen when the triangles parts overlap. Okay, so let's prove this theorem now. Now this theorem we are going to prove like this. As we have been given 2 radius, I'll try to make one more radius to make my life easy. Now I can see these 3 lines, which is my radius, are making 2 isosceles triangles. Taking the isosceles triangle rule, base angles are equal. It means my angle x is my middle angle, which is on the center, and 2 base angles are yellow, which means one angle yellow is equal to 180 minus x divided by 2. Similarly, for y, one green angle is equal to 180 minus y divided by 2. So if I add these 2 angles together on the circumference, I can say 180 minus x plus y divided by 2, which means if I take the angle in the center, which says that angle on the point are always 360, so what I can say that angle blue will be 360 minus x plus y. In this case, I can prove that the angle at the center is twice the angle at the circumference. Don't worry, let's take one more example of the same equation. From the same point where I could say my angle A is equal to x plus y, I have to show that the angle at O is double the angle at A. Okay. Now, taking the example of the isosceles triangle and the base angles and adding up triangle to 180, I can say 180 minus 2x, which is this angle. I have taken this angle. Okay. Now, if I take another angle also, okay, it says, now this is my y, okay, so 180 minus 2y. If I add both of them, I'll get 360 minus 2x minus 2y. Now, taking the rule of angle around the point add up to 360, I can say angle O, which is my this one, angle O is equal to 360, means angle around the point add up to 360 minus the answer I have got here. Okay. Now, following the rule of the BODMAS, because I have been given the bracket here, I can say 360 minus 360 plus 2x plus 2y. Okay. 360 minus 360 is 0. What is remaining is 2x plus 2y, which prove our theorem says angle O is equal to twice the angle x plus twice the angle y. So, by this we can say our theorem is correct and we have proved our theorem. This kind of theorem and or these kind of angles any side on the circle. Okay, so if x is given, you can write 2x. If any angles number is given, you can times it by 2 and say 130 if it's 65, or if sometime you have been given like a quadrilateral here, so if one is 100 then another one is 200. So don't confuse yourself if the shape of the these angles are different. It's for you all to try. Pause the video and try it by yourself. Here are the answers. So in this circle theorem part 1, the circle theorems which are done today, 3 of them are: number 1, angle at the center circle theorem, angle in the same segment circle theorem, and angle in a semicircle theorem. Hope you all managed to understand these 3 theorems out of 7 theorems. Thank you for watching, and our next topic will be circle theorem part 2.